Hi, I am Tom Christensen of Neurochrome. In this video, I will show you how to build one of these amplifiers. This is a Purifi 1ET400A powered by a Hypex SMPS1200. It features speakons and binding posts on the output, and it has XLR balanced input. You can build it with RCAs as well if that's your preference. It is one of the best Class D amplifiers on the market. And stick around and I'll show you how to build one. So for a stereo amplifier, you'll need the following components. First, you need a power supply. This guy here is the Hypex SMPS1200A400. It powers the two Purifi modules. These are the 1ET400A. Each of these Purifi modules need to be fitted with an input buffer, and I use the Neurochrome input buffer for that. And to make the wiring easier on the power supply side, I use this SMPS splitter that I designed, and also to control the power on and off for the amplifier itself, I use this intelligent soft start. Let's take a quick look at the tools you need. I have here some wire strippers, pliers, end cutters. I like using nut drivers rather than wrenches. It's just easier for me to work with. If you have a socket wrench set, this one came out of such a set, it probably has the necessary sizes. You'll need 4.5, 5.5, and 7 millimeters. An adjustable wrench comes in handy for mounting the power switch. I like using a scribe to pry apart the wires that are inside of a shielded cable, and you'll need a permanent marker. You will also need an assortment of screwdrivers. We're talking regular Phillips screwdrivers like this number 1 and number 2. A couple of different flat blade screwdrivers ranging from about 2 millimeters to about 5 millimeters in width. Some Torx screwdrivers. This is a T10, a T20, and this is actually a Torx Plus IP10. In addition, you'll need some kind of crimp tool for spade terminals. It doesn't have to be a fancy ratcheting one like this one, but that is quite nice. This one is by Molex, and it's actually not terribly expensive. But as long as you can make a good crimp, you're good. I recommend that you use bootlace ferrules on some of the connections. It's a recommendation, it's not a requirement, but it does make for a better connection, and a set like this is available online for about 30 bucks, and it even comes with the tool. I'm sure the tool is a copy of a more expensive brand, but I mean, it works well enough. A heat gun and some heat shrink in various colors and sizes can be handy. You'll need some wire. I prefer to use 20 gauge in a couple of different colors for the mains connections and control connections such as the power switch. And I generally use 16 gauge for the output. The wires don't have to be in different colors. That just makes it handy for identification. You can always buy a spool of one color and then color them with colored heat shrink. In addition, you'll need some thermal compound. Arctic Silver is a common brand that you can probably find at a computer repair shop. Alternatively, this is Wakefield 120. The Wakefield 126 works well as well, and that's available at Mauser, DigiKey, the usual suspects. In addition, you'll need some microphone cable. This is way more than you need. You probably need maybe 40-ish centimeters, give or take. And also, the SMPS1200 wiring kit from Hypex can come in handy. I'm a little bit torn as to whether I would recommend that you get this or not, but more on that later. And finally, you do need to solder in 11 places in this amplifier, so you will need a soldering iron and some solder. And if you have questions about which solder to choose, I have a page on my website called Choosing Solder that explains that in quite a bit of detail. So enjoy it. Let's get cracking on the chassis. So this chassis comes out of Japan. It's made by a company called Takashi. I find they make some really nice aluminum chassis. They're a little bit on the pricey side, at least from a DIY perspective, but they are really good bang for the buck. I mean, it's a very nice aluminum chassis. So they come disassembled. So you'll get a bottom panel and a top panel. You'll get a pair of heat sinks, and you will also get, let me put that aside, you will also get a rear panel, a front panel, some side brackets, some rubber feet, and a bag of screws. I don't really care so much for the rubber feet that comes with the chassis, so I choose to buy the fancier feet. They, in my opinion, complete the amp build quite nicely. So let's get started on the front and rear panel. The front panel is the simplest. It only has one hole in it, and that is for the power switch. The power switch is this eSwitch PV6 series. It has an O-ring that comes with it that goes on the switch as well. The rear panel is a bit more complicated. It has the IEC power inlet. It has 2 pairs of binding posts that you can find on my website. It has 2 pairs, or excuse me, it has 2 XLR inputs. It has a Switchcraft 3.5mm jack for the trigger. By the way, that jack comes with these 2 screws. They are US number 4, so if you use the chassis that I provide drawings for, you got to toss those because I use metric hardware only. And finally, you have 2 Neurochrome Beacon connectors for the output of the amp. Let's assemble the front panel. So let's start with the switch. It comes with the nut and it comes with an O-ring. So the O-ring needs to be applied to the switch itself. Just sort of drape it over like that. Ta-da! And then just insert that into the hole in the front panel and install the nut. And just tighten that with an adjustable wrench. Like so. To install the connectors on the rear panel, you need a couple of screws. Specifically, you need 4 of these M3 by 10mm flathead screws, and you need 8 M3 by 6mm flathead screws. So let's drop in the IEC inlet. Just drop that in and attach it with a 6mm long flathead machine screw. Like so. Then let's do the trigger input. And the XLR inputs. And the Beacon outputs. And finally, the binding posts. The binding posts are a little bit tricky in the sense that you have to make sure that the hardware goes on in the right order. So start by taking the nut off and removing the hardware. So you'll find that you have the binding post here with a shoulder washer, and then there's a flat washer, there's the solder lug, a lock washer, and a nut. So the binding post goes through the panel with the shoulder washer inserted into the panel. So let's do that like that. And then on the back side you apply the flat washer, then the solder lug, then the lock washer, and then the nut. And just make sure that flat washer falls into the hole or into that counter bore that's on the inside of the panel. So now the next trick is to make sure that this hole that goes through the binding post is vertical. And I use just a small screwdriver for that. Just sort of make sure that, okay, this is about where I want it to be. And then I tighten the nut. And then just double check. You can always pry a little bit with a screwdriver if you really need to. So there you go. Now that's installed. Now I just need to repeat that 3 more times for the other binding posts. I prefer to mount the amplifier modules on the heatsink. The reason for this is that even though it is a very efficient Class D amplifier design, it does produce a bit of heat, and getting rid of that heat seems prudent. The only drawback of that is that these amplifier modules are mounted with screws that go in from the bottom. So that means that either you need to drill through between the fins of the heatsink, or probably remove some of the fins to get the amplifier module mounted on the heatsink, or you need to make a mounting plate, which is what I have here. So with this mounting plate, I take the amplifier module and the buffer and I turn that into a module that is then bolted onto the heatsink. To build these amplifier modules, we'll need the base plate, we'll need some mounting hardware, and specifically 4 M3x6 flathead screws, 4 M3x16 flathead screws, 4 8mm long standoffs, and 4 hex nuts. We'll need the Neurochrome input buffer, and we'll need the Purifi amplifier module. Although it might not be strictly necessary, I prefer to apply a little bit of thermal grease between the amplifier module itself and the base plate, just to ensure good heat transfer. So let's apply that. I just dipped my finger into the grease here and kind of smear it on there, sort of a little bit haphazardly. I will explain why in a bit. And have a rag handy because it is pretty messy to work with. Then I take a blade from a utility knife and just scrape that so I get a thin coat that's reasonably uniform. You don't need a lot of thermal grease, you just need enough to cover any surface imperfections. And then I attach the amplifier module to the base plate. Oh, I guess it does help if I line it up with the correct holes here. So let's do that. There we go. Okay, like that. So next up is the buffer itself. It sits on these 3mm by 16mm long machine screws and some standoffs. So the easiest way is to get the screws just partly through, just into the standoffs like that. These standoffs are kind of handy in the sense that they have a feature on the inside that captures the screw. So you can get them in place without everything falling apart as you move things around here. It looks like I have some thermal grease on the bracket here. Get that off. There. And last one. Like that. And then basically you attach the buffer. just plugs straight into the amplifier module, like that. Let's get the screws through. And then secure the board with the hex nuts. Just like that. And now we have completed amplifier module. The amplifier module is attached to the heatsink using 4 M4 by 6mm long machine screws. Between the module itself and the heatsink, I will apply a thin coat of thermal paste. So same deal as before, where apply a decent amount of thermal grease. Try to get it somewhat evenly distributed. And then level it with a utility knife blade. Like that. Then attach it to the heatsink. And I see I have a little bit of excess thermal grease here. I'll just wipe that off. And there you have it. So now we have an amplifier with buffer on a heatsink. So now I just make a mirror image of this for the other side of the chassis, and we're good to go. Okay, so with the amplifier modules mounted to the heat sinks, it's now time for the corner brackets. That's these guys. So they mount to the corner like that with some M3 by 6mm flathead machine screws. So in the bag that you get from Takashi with the screws, you will find two screw types. One is a flathead. Its top of the head is completely flat. And you will also find another type, let me see if I can find one here, like this guy, where it's an oval head. So the head is a little bit domed. The oval heads are for the outside of the chassis, and the flat heads are for the inside of the chassis. So let's start by sorting the screws into oval and flat heads. Now all we have left to do is to turn some screws. So once again, the internal screws are the ones with the flat head. So two flat head M3s go into each corner bracket like so. And just continue for the remaining brackets. And just like that, we have the completed heatsink with amplifier ready to mount in the chassis. You need to solder in a couple of spots in this amp. And this is a lot easier to do before you put the chassis together than after. So I'll start with the front panel. You need to make 4 solder joints to the switch. And those are for 2 connections for the LED and 2 connections for the switch itself. I like using different colored wires so I can tell the connections apart, but I mean the electrons don't care. And you can always color the wire with like colored heat shrink or electrical tape. I like using green for the green LED and red for the red LED, and then I used brown for the switch. So to tell these pins apart on the switch itself, it's marked on two sides. On one side it says R1.8V plus, and on the other side it says G2.8V minus. So the R is for the red LED and the G is for the green LED. So I'll solder the red wire to the red and green wire to the green. The other two terminals are not marked, and they're also gold plated, whereas the ones for the LEDs are tin plated. So the two gold plated terminals are for the switch itself, and I'll attach the brown wire to that. You need about 30-40 centimeters of each. 30-40 centimeters of the red and green, and then about 60 to 80 centimeters, give or take, of the brown, because you have two of them. So let's get cracking. And I'm just going to strip the wire here. Oh, come on. And I'm going to attach that to the green terminal. And I'll just solder real quick. Like that. And just repeat for the other wires. And here is the completed wiring harness for the power switch. I will put this aside for now and now go work on the rear panel. The rear panel is a bit more involved. That's simply because of the number of connections on the rear panel. So I'll start with the input wiring. I use a microphone cable for this. So this has 2 conductors and 1 shield, and that gets soldered onto the XLR connectors. I'll start by stripping off a bit of the outer jacket. This is maybe, I don't know, 20-25 centimeters of wire. That's probably a bit longer than I need, actually, but it's better to have a little too much than not enough. So let's start by stripping off about 20 millimeters of the insulation. So I slice through maybe about halfway, and then you can bend over the insulation and just touch it with the knife, and then it comes apart like that. And that avoids nicking the wires that are in the shield. And looks like there's a little bit of the jacket left here. Let's see if we can get that to cooperate. There you go. Ta-da! So now we have a nicely stripped wire. So the next thing you need to do is to unbraid this braided shield. And that can be a bit of a pain, but I find that with a scribe, you can sort of pry it apart gently. You don't want to break the wires. Ideally, none of them should break, but usually I end up tearing off one or two. So like that. And then bend this out of the way. And then I twist the shield together. Like so. And this weird paper stuff or thread, whatever it is, let's just get rid of that. Like that. And there's one of the wire strands. So let's get rid of that. What I then like to do is to tin just the tip of the shield itself. Just apply a little bit of solder near the end. Like so, because that allows me to cut the end flush without losing all the wire strands. So now we are ready to attach it to the XLR connector. pin 1 of the XLR connector should be grounded to the chassis. And that's done with this chassis tab right here. So what I like to do is I take a piece of resistor lead and bend it and then just make that connection. So that's done like so. I bend it at about a little more than 90 degrees. And then I thread it through the chassis tab and into pin 1. I guess I got a little bit too much. Let's chop a little bit off. There. All right, like that. Oh, come on. There we go. So now I have pin 1 and the chassis connected together, at least as soon as I complete the solder joint. Shit. There. Excellent. Now we just do the same thing for the other side. There you go. And solder. Just like that. And now it's time for the wire. So there is always the risk of having a couple of frayed pieces of wire from the shield. So to prevent those from going everywhere, I like to put a little bit of heat shrink on it. So just enough that we get like a little bit of an exposed tail here. This might be a little bit too long. That. Ta-da. And I will then also drape a larger diameter heat shrink over the wire, like so. So after the soldering is completed, this turns into a nice and tight, isolated little junction. So let's start with the shield. Actually, let's start by stripping the wires here. And give them a little bit of tin. There we go. Oh. And now let's solder that to pin 1. So it can be a bit tricky to hold everything in one piece or in one place with only 2 hands and 1 hand holding the soldering iron. So what I find is that these clamps are quite nice. They're a couple of bucks at the home improvement warehouse, and ta-da! Now we have a 3rd hand. And let's solder that wire on there. Ta-da. So that was the shield. And then we need pin 3 and pin 2. The pin numbers are marked on the inside of the connector. Pin 3 is the one towards the top, and that is the cold connection. So I'm going to use the blue wire for that. Just going to tin the cup a little bit. And then maybe I should use the pliers so I don't burn myself. Come on. Ta-da! And then let's just finish the job here. The white wire goes to pin 2. Oh, come on. And there you go. Now all I have to do is to apply that bit of heat shrink wherever that went, and I'm set to go with the next connector. As you may have noticed, I pulled my desk lamp in so that I could see a little bit better. Unfortunately, that meant that it blocked the view of the overhead camera. So let's try again on the second connector. Hopefully you can get a little bit better picture here. So for the second connector, let's take the shield of the cable and jam it into pin 1 like so. And apply some solder. And there you have it. So that's the shield. So now we need the hot and cold wires, and then the connectors basically soldered. So let's do that. As before, I start by tinning the solder cup on the connector. Let's just do that for both of them. And then I use the blue for the cold connection. And the white for the hot connection. Like that. So regarding the color scheme, I'm not really sure if there is a standard or not. Like I mentioned earlier, it's not like the electrons will care. So I associate blue with cold, so that makes it easy for me to remember. Now the last piece is this little bit of heat shrink that needs to get on to the cable and cover the shield just so it's not exposed. And let me see if I can untangle my heat gun here. And like that. Knock it off. So next up is the speaker connections. I'm a big fan of the Neurochrome speak-on connectors, and the reason for this is pretty obvious. This goes on the chassis. It's a 4-pole connector, so it makes 4 connections at one time. It's impossible to make a short circuit between the poles, and each pole supports 30 amps of current. So one of the reasons I like them is that it's impossible to make a wrong connection. I just made 4 connections right there. None of them got crossed. It doesn't come undone, unlike binding posts that you need to go in and tighten periodically, and it easily just comes apart like that. These have been used in pro audio for decades, and they're finally now getting some traction in the audiophile community as well. I'm really not a fan of the binding post, but I do accept that it's, you know, the standard in audiophile equipment. So anyway, without further ado, let's get these things wired up. So what I like to do, like I mentioned, there are 4 poles in the speak-on connectors. I use the first pole pair for the amplifier output, so the left connector will have the left channel on pair 1, plus and minus, and then on one of the connectors I bring out both channels, so I have both left and right channel on the same 4-pole connector. That makes the amplifier really easy to use in a vertical biamp. You just plug in, you know, one speaker cable into that one connector and bam, off you go. So let's get that wired up. You'll need some 16 gauge cable. I mean, you can use heavier gauge if you like, but 16 is plenty. And you'll probably need about 2-ish meters total. So I'd sort of do it a little bit by just by ear here. I want to connect from here, from the speak-on connector to the binding post, so I'll need about this much wire. So let's just lop that off, and ta-da! I'll need a piece from the binding post to the amp itself. Don't know exactly how much, but this is like 20-25 centimeters, and that's probably plenty. So I'll do that. And let's just strip off the insulation here. And like that. And get the soldering iron going. And then I will solder that to that one binding post. There is just enough room for both wires in that soldered lug there. Oh, come on, you've done this before. Get in there. I swear there's enough room. There you go. And there we have it. Now all I need to do is solder. Ta-da. And repeat for the other connections. Okay, so I now have the wires soldered onto the binding posts, and it's now time for adding the crimp terminals that will connect to the speak-on connectors. So to do that, I'll just take the one wire pair, the shortest wire pair here. I made them a little bit longer than I needed to. So I'll just sort of fiddle with it until I get, this is about the length I want. Let's chop that off. And then strip off like 8-ish millimeters, give or take. There we go. So on this side, I'm going to connect, this is for the binding post, so that goes to pair 1 of the speak-on, and that pair 1 also is connected with these longer wires to pair 2 on the other speak-on. That's for the bi-wire, or excuse me, bi-amp feature of this amplifier. So I'll need to squeeze in 2 wires. Let me just strip the insulation off this guy, and then those two go together, and a crimp terminal. You want the wires just poking through on the other side, and then I just crimp it. Ta-da! Just like that. Now I just need to do that 3 more times, and we can wire this whole thing up. I now have all the crimp terminals added to the wires. I'll color the wire ends with some colored heat shrink, just so to make it easier to identify the terminals later in case you need to repair the amp or something like that, but also just to make it a little more clear in the video so you can tell where the wires go. With the wires colored with heat shrink, I can now make the connections. So let's start with the plus here on this side. That should go to pair 1 plus, which is this terminal here. This wire goes to pair 2 plus on the other side. Then on this side, the plus goes to pair 1 plus, which is there. The polarity is marked on the back side of the speak-on connectors. That makes this rather easy. Then the minus side goes to pair 1 minus. Like that. This guy here Goes to 1 minus on this side and 2 minus on the other side. Like that. Cool. So these connections are for the amplifiers, and these are the inputs to the amps. So now all that I have left to do on the rear panel is the mains and the trigger input. So let's do that. I'll use my handy dandy third hand again. Like so. And then I've already stripped the insulation from the mains wiring. I'll use this yellow-green for the ground, or protective earth, if you will. That is a safety feature, so you gotta get that on the ground terminal here. Let's see. There you have it. And now I use white for neutral and black for live, and solder those on the back of the IEC connector as well. Neutral is marked with an N. So let's get that one in there. Like that. And now all I have left to do is to cover the mains connections with some heat shrink, and we're ready for the trigger. Now that I have the mains connections protected by heat shrink, I'll solder up the trigger. So I've chosen blue for trigger minus and orange for trigger plus, and that goes on the back of this Switchcraft 3.5mm jack. One terminal on that is marked with a T, and that goes with the tip, and that's for trigger plus. So I'll solder the orange wire onto that. And the sleeve goes to trigger minus, and that terminal is pretty easy to find because there's a large metal sleeve around the jack here, and one terminal is connected to that. So even though it's not marked, it's pretty easy to identify. And let's get that on there. There. Ta-da! Now the rear panel is done. So here I have the completed rear panel with one of the amplifier modules on the heatsink. And I'm just going to put these two together, sort of dry fit. This is how it comes together. And I'm going to use that to measure or determine the length of this microphone cable. As you can see, I have way too much, and I don't want to just coil it up. So I'm going to see here. I'm going to need about yay much. I want to leave a little bit of slop or slack in the cable, just so I don't want to, you know, all tight clothesline here. And then just chop. And let's do the same on the other side. Need this much cable, a little bit extra. There we go. Cool. So now I can put this aside, and I can strip these pieces of microphone cable. It's a lot easier to do when you can move the back panel around a bit, rather than try to assemble the amp first and then try to mess with this. So let's just get the trusty utility knife. I want to strip maybe 20-25 millimeters of the outer jacket. This is going to be a bit tough to see. There we go. Careful not to cut yourself, and don't slice into the braid of the cable either. So there, like before, you can just sort of bend the insulation and it'll come right off, like so. And just like before, I'll use the scribe to get the shield separated, and I'll do that on the other side as well, and I'll see you in a bit. I now have the outer jacket of the insulation removed from the microphone cable. And I separated the strands of the shield, as I showed you earlier, and twisted them into a tight bundle. But unlike before, I do not want to put solder on the tip here. And the reason for that is that this is going to go into a screw terminal. And if you put solder on a wire that goes into a screw terminal, the solder will compress from the pressure of the terminal, and over time that connection will weaken, and the wire can fall out. So let's avoid that. But that also means that when I go to cut the tip off of the shield here, I gotta be careful that I don't lose all those wire strands everywhere. So I'll just cover the end of the cutters like that, and then this goes in the garbage. So now with the microphone cable prepared, I will drape it with a little bit of heat shrink, just like so. And I'm going to strip the insulation off the two signal wires. I want to be a little bit generous, probably like 6 to 8 millimeters, give or take, is what I want to remove here. And the reason for that is that we'll twist the strands inside. And then I'll use the flat blade screwdriver and just fold them over. Like that. Because that gives the screw terminal some decent amount of wire to clamp onto. Just clean that up, and then I use a smaller piece of heat shrink on the shield. That may be a little bit too much. I'll just adjust it to size here. Like so. And I'll shrink that so that it covers the shield. Then I will drape over the larger heat shrink so that it covers all the, or just a little bit of the exposed shield at the end there. Like that. So now let's start assembling the rear panel and the heat sinks. So come together like so. Obviously the buffer goes towards the rear panel. And then with the flathead screws and a Phillips number 2, let's get that attached together, and then turn it over for the screw on the bottom side. Like so. And then what I want to connect is this microphone cable. So let me just make sure there are no stray strands here. And then, let's see. It's usually easiest to connect the signal wires first. And remember, blue was cold. So blue goes to pin 3. That's marked in minus. White goes to pin 2. Which is marked in plus. Like so. And then finally the shield goes to pin 1. Just like that. And now just repeat for the other side. So next up are the speaker connections. And thankfully I left the wires a bit long here so that they will reach the speaker connections. If you want to get a little fancy, you can use a bootlace ferrule at the end of the wire. And that's these guys. So you can get a setup like this for roughly 30 bucks online. And it's kind of a nice thing to do because it prevents the wire from wiggling free from the terminal. Stranded wire has a tendency to sort of, the strands over time will shift a little bit, and sometimes that can cause them to let go from the screw terminal. So this bootlace ferrule prevents that from happening. So I will cut these to length. I think I'm gonna go with, like, yay is good. So I'll just cut that off and strip the wire. I'll strip about, let me pick the right size here. So this is for 16 gauge. I want to strip a little bit longer than the tip of the ferrule. So about like yay. Oh, come on. There we go. And then add the ferrule. Oh, it's a little bit short. Oh, come on. There we go. And you should just see the end of the wire kind of flush with the ferrule. Then I'll grab the crimp tool and ta-da! Now we have a bootlace ferrule. And I'll just repeat that for the other 3 connections, and then I'm ready to hook it up. And there you have it. I now have the bootlace ferrules on all the speaker connections. I'm just going to mark the plus with a bit of red heat shrink, just to be nice. And now let's make the output connections. So you'll need a flat blade screwdriver, and the plus goes into the plus. It's marked out plus, which is the furthest inside terminal. Like that. And minus is then the other terminal. Let's get in there. Now let's repeat for the other side. So out plus is that guy. And out minus is this guy. Get in there. There. Like so. And now it's time for the bottom. This is the bottom panel. It will hold the SMPS1200A400. It will hold the Intelligent Soft Start and the SMPS splitter. But before we can get started, we need to remove a protective foil that's on the back. So you'll notice that one side is sort of dull and the other side has a pretty clear sheen to it. almost like it's reflective. And that's because of a protective plastic film that we need to remove. It's just like an adhesive tape, like that. Alrighty. So now we can mount the components. I'll start with some 10mm standoffs. So these are hex standoffs. You can use like hollow, just regular standoffs, but I like the threaded ones because then I can attach them to the panel itself, and that just makes the assembly go a bit easier. So I'll start with the ones for the ISS. And now 4 standoffs for the SMPS splitter. Like that. Now all I need to do is tighten these with the nut driver and a Torx T10, and we're good to go. Before I start mounting the switch mode power supply and the remaining components, let me just add the grounding lug. So that goes on with a M3 by 6mm long machine screw and is attached to the inside with the locking nut. Like so. Let me just tighten that up. I want the solder lug to face the rear panel, so I'll attach it like so. So now let's add the switching power supply and the remaining components. So with the switching power supply, it's also attached, like the amplifier was, it's attached with screws from the bottom, and you want to make sure that they don't protrude too far into the supply itself. Hypex specifies that you can protrude by 4mm, so these screws are M3 by 6mm long. The panel is 2mm thick, so that allows for just 4mm of protrusion. So let's get that on there. The mains input for the supply is here, and the ISS is going to go here. So I want the mains wiring to be as short as possible, so I'll orient the power supply this way. Let me see if I can get the holes aligned here. There we go. Just get one started, then the opposite corner, and now we can tighten them. And just finish for the, or continue for the remaining 4 screws. And now with the power supply mounted, it's time for the other 2 boards. So I'll start with the SMPS splitter. I'll just orient the plugs so that they point the same way as the output plug on the switching power supply, and attach the board with 4 screws. And now for the ISS. So the mains end of the ISS is this end, and I'll align that with the mains input here on the power supply. So all the mains business go in one end, and just attach with 4 screws. Just like that. So I should note with the ISS, you do want at least 10 millimeters long standoffs. They can be plastic or they can be metal, that's your choice. I generally prefer metal because it doesn't strip and it doesn't warp with temperature and whatever else. But they do have to be at least 10 millimeters long, and this is for the safety clearance underneath the board. And now it's time for the feet. I like these slightly fancier aluminum feet from Takashi. They're quite a bit nicer than the stick-on rubber ones that come with the chassis, so I choose these instead. They attach with a 4mm machine screw that's 16 millimeters long. Just feed it through like that. Pop it through the bottom of the panel. Add a lock washer and a nut. And tighten it up. And then repeat for the other 3 feet. Just like that. So now we have a bottom panel. So now back to the rest of the chassis here. We have the rear panel facing away and then the heat sinks on the side. So I'm going to grab the bottom panel with the ISS pointing towards the rear panel, and I'm just going to set it in there. And hopefully you remember that the oval head screws go on the outside of the chassis. Takashi makes some slightly fancier oval head screws. They charge a bit extra for them, but they have Torx drive, and they look nicer. And Torx tend to be more audiophile approved, so I will use the Torx drive and just drop those in. So there's 1 on each heat sink and 2 on the front panel and 2 on the rear panel. So let's get this in there. Leave it a little bit loose until I get a couple of screws in here. There. I'll just make sure, now that I have 2 screws in there kind of loosely, I'll just make sure the chassis is square, and then I'll get the remaining screws in and tighten them all up. Like that. So now let's turn it upside down, or rather right side up. So the grounding wire, the yellow and green wire that connects to the protective earth terminal of the IEC inlet, needs to be soldered to that grounding lug at the bottom of the chassis. So I'll just gauge how much wire is needed here. The wire should ideally be as short as possible. That's about yay much, and then I will cut that off. Get the soldering iron going and strip the wire. Like so. And then get it into the solder lug. Just like that. And now we solder. Just like that. And now all we have to do, so we have mains wiring and we have the trigger input. Let's get those hooked up. I'm not really a fan of exposed mains wiring inside of the chassis. So even though the insulation on these wires for the mains is rated for 600 volts, I've still draped it with some heat shrink. That also makes it look a bit nicer. And in addition, I stripped the ends and put some bootlace ferrules on there. So let's get this hooked up to the ISS. So the input of the ISS for the mains is here, and hot and neutral are marked on the board. The neutral is the one closest to the edge. So I will connect that to the white wire and connect, let's see, I need to open these terminals a little bit. There we go. Neutral goes to the terminal closest to the edge of the board, and hot goes towards the inside. Just make sure these bootlace ferrules make it all the way into the terminal and tighten. And there you have it. So now let's hook up the trigger. So same deal as earlier, where, let's see, I forget exactly which terminal they hook up to. I'm gonna have to look that up, but the wire needs to be about this long. So I'll just chop it off, strip the ends, and connect to the appropriate terminals. So next up is the front panel. And it attaches to the heat sinks through these holes that go on the bottom. So as you can see, I got kind of ahead of myself here because the bottom plate blocks access to these screw holes. So let me fix that. I'll just turn this upside down and remove the screws that hold the bottom plate. Like that. And then I can just scoot the bottom enough that I can gain access to these screw holes, and then mount the front panel. So I prefer the panel mounted like this with the power button towards the bottom. So I will scoot it in like so, and use the 4 remaining flathead screws to mount it. Like that. That was the first 2. I can now get the bottom back on, and then I'll do the 2 from the top in a moment. Alright, cool. So now there's a little bit of mess of wiring that should get tidied up a little bit. I'll add some wire ties, and I'll also add some wire ties back here just to clean things up a little bit. And now with the wiring cleaned up, I can connect the power switch to the ISS. Like that. And now I'm ready to connect the power supply to the ISS on the main side. So when you buy the power supply, you can choose to buy this wiring kit. It's €10, which is actually a pretty good deal compared to what's in it. But I find that I end up not using a lot of the bits. I'm going to use a couple of them, but I will also provide part numbers for replacements. They can get a DigiKey, for example. So this is the mains connection, and that plugs in there, and then that's where the power comes in. So I'm going to connect that to the output of the ISS. So I'll just trim these leads to length, like so, and come on, unplug, and I'll add a bootlace ferrule on each of these. So just like that. I'll drape these with heat shrink as well, just to prevent too much exposed mains wiring. So let me just do that. Ta-da! So now this is ready for use. I'll just plug it in and then connect, let's see here, the neutral goes on the neutral end. So that will be terminal 1 here on the ISS output. And then the live goes on the other end. like that. Ta-da! So now I'm ready to hook the power supply up to the amplifier modules. So I'll need the 6-pin harness for the main power, and then I'll need the 10-pin ribbon cable for the auxiliary power. And the ribbon cable I make custom because they're pretty easy to make, and then I get the exact length that I need. So now for the ribbon cable. You'll need probably about 40 to 50 centimeters of it, along with 3 of these IDC connectors. So each connector has the connector piece. It has a dealy bob that squishes down on the cable and locks it in place, and it has a strain relief. So let's start by taking the strain relief out. And if you notice on these ribbon cable connectors, they have a key, and then there's a little arrow that marks pin 1. So let's line that up with pin 1 of the cable, like so. It just threads through, and then the clamping piece on top has these little indentations in it that line up with the wires of the ribbon cable. So you put it together like so. Make sure that the connector is on the cable squarely. And then I like to use the yoke of a pair of pliers here. I just put that on top and then press down. Usually there's an audible click, but not in this case. What you do want to make sure, so from this clamping piece, there's a pair of ears that come down and they lock over a little plastic latch. That's usually what generates the click. And you do want to make sure that they're all the way inside so that they're locked all the way. And then you just fold the cable over and attach, come on, the strain relief. Like so, it just clicks in. So that's one end. Now I need to know where to place the other connectors. And the easiest way to do that is to get the amp back over here. So now that I have the amp handy, I can get the length of the ribbon cable. I do that by plugging the connector into the buffer. So pin 1 marked with the red wire, and pin 1 is marked with a little arrow on the buffer. So I just plug that in, and then I just sort of use my usual hand wavy way of doing things here. I do want to make room for this cable, the main power supply cable. So I need a little bit of slack, maybe like so. That's probably about right. So I want the connector to be placed there. So I'm just going to mark that with a permanent marker, like so. It doesn't have to be rocket science. And then unplug and grab the next connector, which I'm sure disappeared. Here it is. Grab the next connector, and this is where you want to pay attention. So there's the key and there's pin 1. So it's kind of nice to have the keys facing the same way. And you have the key here and you have pin 1. So I want the connector aligned like so. And I feed it through until I reach my mark. Oops. Sometimes the connector falls off. That's no big deal. Just put it back on. And now where was my mark? Oh, there it is. So I align the connector with that mark and make sure all the wires are perpendicular to the connector itself, and then squeeze down. And there you got the little click. And now I just fold the cable back over and attach the strain relief. Get in there. There. So now this should work. So we have that. And we have that. And there's room for the power supply wiring to come out. So now we just do it again for the next one. So with my mark on the cable, I now know that I want the connector to be mounted like so, but I also want to account for the length of cable that's used in the strain relief. So the cable is to go around the strain relief like that and then attach to the connector like so. So I'll just feed the connector on. Come on. Make sure that you get the pin 1 and the red wire aligned here. So there's my pen mark. So I want the connector to be about there. And same procedure as last time. Make sure the connector is perpendicular to the cable and push down. And it's locked all the way. Cool. And then I will slice off the extra cable. You can do that just with a utility knife. Don't slice your thumb. And fold the cable over. Oh, come on. Like that. Ta-da! So now I have the cable for the auxiliary power supply. So I'll plug that in. And the beauty of this, it's now all keyed. So it's as long as you get pin 1 aligned with pin 1 everywhere, then everything works out beautifully, like so. So now all I have to do is the main power wiring. In the wiring kit from Hypex, you find a harness like this. And you can, if you have 3 of them, you can fashion a Y cable. So basically you have one connector here that branches off into a connector for each of the amplifiers. I found that, I did that in my first build, and I found it to be pretty unwieldy actually, because these are, I think, 12 gauge wires. They're pretty heavy anyway. So the solder joint gets pretty clunky. So that's why I designed the SMPS splitter. The drawback of the splitter is that you need 3 cables, each with, one of these connectors at each end. But thankfully, DigiKey comes to the rescue because they provide some pre-crimped leads that come in various lengths that will plug into the splitter and into the power supply and the amp modules. So now with this done, it's time for the next harness. It needs to be a bit longer. These are 12-inch wires, so twice as long. That's probably a bit too long. I forget if you can get a 10-inch version of them. I know that the 8-inch is just too short, so 12 inches it is. Also note that these connector pieces are a bit different from the other ones here. So these ones have an external latch and these ones have an internal latch. Functionally, they're the same. The internal latch is just a little bit more compact, and sometimes that's in stock where the other one is not, or vice versa. So same deal, latch facing up. I'll stab the wire in upper left, latch facing up, wire in upper left, middle to middle, and upper right to upper right, there, upper right, and so on. Ta-da! So now we're ready to install these in the amplifier. So let's get the amp up here. And let's plug this in. Plug that into the right side channel. Like so. Let's see if we can get this draped so that it doesn't pull the ribbon cable out. Like that. That's cool. So they're a bit long, but of course better too long than too short. And then let's get the 6-pin harness plugged in to the SMPS splitter and then into the buffer, like so. Now the amp's done. The only thing there's left to do is to make sure you have the correct mains voltage selected on the SMPS1200. That happens on this jumper down here. It needs to be open like it is right now if you're using 230 or 240 volt mains. If you're using 120 volts mains, so like in North America, you need to put a jumper across there. So if you buy the wiring kit for the Hypex, or for the SMPS1200, it comes with this little connector bit and a pair of terminals. So you can fashion a jumper out of that, but if you bought my ISS, or Intelligent Soft Start, you got a little baggie with a couple of jumper wires. You can buy these at DigiKey if you need one. And those fit handily into this here connector. There's a little locking tab there that faces this window here, so just pop it in, bend over, pop in, and now we have a jumper. So I'll plug that in because I am in Canada and we use 115 or 120 volt mains. What I'd like to do now is just clean this up with some wire ties, make sure that it all folds down nicely once the cover is put on. I might have to squeeze it a little bit, but that's okay. But basically the amp is done. I like to test the amp before I put the cover on. It's just easier that way. So let's start by, well, I just found this. This is the fuse drawer. So that goes in there and should have a fuse in it. So I guess we're not quite done, but I'm getting anxious. So let's put a fuse in there and see if we can wrap this baby up. Alright, so I dug up this 10 amp fuse. It is a 5x20mm cartridge fuse, and you pop it in to the holder like so, and then it just scoots into the IEC inlet like that. And now we have a fused inlet. So let's plug this baby in. Okay, no sparks, no smoke, and we have a red light on the front, just as I'd expected. So that is the standby light. Let me just adjust the brightness of that, because I prefer my LEDs, my indicator LEDs, I like them a little bit dim. So I will use the dimmer to get it roughly where I want it. So about there. Then let's hit the button. Click of the relay. This is a good thing. Light turns green. It's a little bit bright, so I'll adjust the brightness. And that's about right. Ta-da! And now what's left is to test the amp. And I have the Audio Precision APX 555, so I'll plug it in. I obviously don't expect you to have a distortion analyzer on hand, and you don't need one. I mean, at this point, what I would suggest that you do is to measure the DC offset on the output of the amp, and that can be done with a simple handheld multimeter. And if the DC offset is low, then connect the test speaker and a signal source and see if you can play some music. So let's do it. So the amp tests out to my satisfaction. Now what I want to do is to put the top panel on. And it's the same deal as with the bottom panel, where one side is a little bit matte and the other side is more shiny. And the shininess is this protective film, or protective foil here. So let's just remove that. So as you can see, the wiring is a little bit in the way, but that's just the way it is, unfortunately. So I will start with one. I'll just get the screw started and then align the panel. Oh, come on. There, just get it in there. Like that. And tighten. And then the remaining 4 screws. And as usual, these are the oval heads, and they're the fancy ones with Torx drive. Ta-da! Congratulations on the build, well done.